I hope you can hear me. You can see the screen.
Yes.
All right. Thank you very much. So I'm Matteo Crachi, a PhD student from the Department of Mechanical and Aerospace Engineering at the Politecnico di Torino. And basically today I have the pleasure to introduce to you our recent research work, basically done together with Professoressa Sesana and Delprete from the same department, about the indentations as effect on additive manufactured design of experiment of a nickel-based alloy. Basically, our research group works on different topics. My PhD is focusing on the liquid rocket engines, and because of the interest in nickel-based alloy, today I'm here to present to you this new activity we have done. The agenda of today, I will quickly go through the objective of this research, material and methods, the results. So basically the identification of the correct load in order to characterize the hardness map of our design of experiment. And then I will go through the quickly presentation of the indentation size effect we found out with respect to different plane, so the XY plane parallel to the building platform, and the ZX, or if you prefer, ZY plane, with respect to different condition, the as-built condition, the heat-treated condition, by finishing with some conclusion and future the developments. The objective of this of the present work are basically we would like to target the correct load for hardness evaluation of nickel-based alloys with respect to our design of experiments. So the question was, which is the correct load to use in order to basically characterize the hardness with respect to the whole platform. And basically what we've done, we would like to present is the evaluation of the hardness on different platform position by varying the radial angle and not the radial position. I will explain on a few on the next slide this sentence, and then basically analyze the dependency on the indentation side of effect with respect to the energy density, the indentation planes, and the heat treatment, or basically the specimen conditions. So few words about material and methods. So basically what we have done is we printed our specimen cuboid 20 millimeter specimens with the laser power bed fusion technology. So we divided our building platform in 4 different squared areas, as you might see on the right hand representation, and basically our specimen differs because of the energy density combination. By this, I mean, what we have done is we modify the laser power. So basically we have 2 main laser power and the different scanning speed in order to have 7 different specimens, and basically we replicate the 7 different specimens in our 4 areas. Micrography measurement have been used to identify the melting pool size, and they have been performed with a Leica inverted microscope, and ImageJ open source software has been employed in order to characterize the melting pool dimensions and geometry. Beaker hardness measurement to characterize basically the scattering on the mechanical properties with respect to the platform specimen's position. And then we, in order to characterize the indentation size effect, we selected randomly a quadrant, so the bottom left C quadrant, Beaker's micro indenter, 5 different loads. So we started from 1 kilogram down to 25 grams, and basically 5 repetition per selected load in a random area with respect to the analyzed printing plane. What we have done is basically target the 2 planes, so the XY and the ZY or ZX plane, if you prefer, and basically two main conditions, the as-built one and a direct aging condition. So I heat-treat the specimen, and we, in order to target a good quality for the hardness indentation, what we've done is basically we polished the XY and the ZX plane, the ZX plane. So the first, basically, our first topic was to identify the correct load in order to map the hardness around the platform. What we've done was basically we identify the higher relative density specimen, which was actually the C2, XY plane and ZX plane, were analyzed in order to identify the hardness load. So as you can see by the bottom left chart, the hardness measurement shows an indentation size effect and a reverse indentation size effect. If then we analyze, what we've done basically is analyzing the hardness depth of the hardness depth, and basically we use this in order to identify the maximum load to penetrate not more than two melting pools. So the result shows that actually the 20 kilograms Vickers load has been chosen to the hardness map that I will present to you in the next slide. And this was because basically of the low scattering, and then it was the closer, let's say closer to the zone that is not affected by the indentation and the reverse indentation size effect. And basically, because we think that the reverse indentation size effect is linked to the melting pools, we identify this load in order to be sure that we do not penetrate more than two melting pools. Here, a quick, a preliminary representation of the Vickers 20 kilograms map analysis, and it shows a good hardness independency from the quadrant position only with respect to the XY plane. Here, just an example, so specimen number 7, the XZ plane seems to be more affected by the position on the building platform. The XY plane hardness measurement about this plane, so the bottom left chart, you can clearly see that the hardness seems to be not affected by the energy density. So by increasing the energy density, the hardness seems to be not affected. The as-built specimens show a low energy density dependency, as you might see on the bottom area of this chart. On the other side, the heat-treated specimens are not affected by energy density variation. On the other side, the XY plane, presented on the right side, we can clearly see that hardness is strongly affected by the energy density for both, so the as-built and the heat-treated condition, and they show a strong energy density dependency. All these results have been published on our recent publication that you might see on the top right area. One of the reasons why you can probably see this kind of scattering from our point of view is because of the scanning strategy. So we used island scanning strategy, and if you think about the layer by layer deposition and the strategy, we think that the arrangement of the strips can affect the measurement, especially on that plane, and this could be one of the justification for this scattering. About the indentation size effect, so what we have done is we identify for this study only one quadrant, so quadrant number C, bottom left one, And we will basically analyze the hardness with respect to the seven combination of energy density from 1 kilogram down to 25 grams. And basically for both the XY and the ZX plane, they show basically a remarkable indentation size effect for both condition, the as-built and the heat-treated one. By plotting the difference between the maximum and the minimum value of all indentation size effect curves, it is possible to identify a dependency between the indentation size effect and the energy density. So the general trend shows a reduction of the indentation size effect with the increase of the energy density, except from the heat-treated XY plane, so on that area. About the ZX plane, the indentation size effect, there is a reduction rather than the XY plane, and it is less affected by the energy density. So by just comparing the slope of these two curves, you can definitely see that the XY plane seems to be less affected by the energy density. Just to conclude, so laser power bed fusion additive manufacturing nickel-based alloys are affected by the indentation size effect and the reverse indentation size effect. The printing position seems to have a higher scattering effect on the ZX plane hardness measurement and a lower scattering effect on the XY plane measurement. The ZX plane hardness rather than the XY plane is higher affected by the energy density. The indentation size effect is affected by the energy density and the analyzed plane. Higher energy density deposition leads to a lower hardness variation, so a lower indentation size effect. And on the other side, higher on the XY plane. Heat treatment tends to reduce the indentation size effect only with respect to the XY plane. For the future development, we think that the analysis of the relation between the indentation size effect and the melting pool internal grind size by ABSD analysis should be performed, and we would like to extend this study with respect to the reverse indentation size effect. I would like to thank you for the attention. We work also on metal matrix composite, basically copper and maraging steel. I've seen many interesting works on that topic. So if you're interested on some cooperation between Politecnico di Torino, the Italian Space Agency, and an Italian private company, which is Sofiatech, we have the pleasure to stay in contact. So thank you for the attention.